Hi guys, welcome to today's tutorial. Welcome to Mathematics Simplified. Today we'll be considering some past questions for WIEC, NECO, GC, JAMB. Alright, top past questions from major exams. Okay, now our first question says, a palm fruit dropped to the ground from the top of a tree 45 meters tall. How long does it take to reach the ground? Now, for us to calculate how long it takes to reach the ground, we'll be using a formula S equals UT plus half AT squared, which is one of the formulas for the laws of motion. Okay, now where our S is the height, all right, and our U is our initial velocity, our T is the time, okay, taken, and A is acceleration due to gravity. Okay, so here now, from here, we can now calculate our T. All right, our S given, let's say, given S, which is the height, is the distance is the height of the tree, 45 meters. Okay, and our U, initial velocity, since it was at rest, it would be 0. Then A, acceleration due to gravity, is 10. Okay, that's always constant, 9.8 or 10. So now substituting this formula, substituting this into your equation, this becomes 45 equals 0 times t plus half times 10 t squared. Okay, so 45 equals 0 plus 5t squared. Okay, so 5t squared equals 45. So t squared equals 45 over 5, which gives us 9. So t equals the square root of 9, which is 3 seconds. So it takes 3 seconds for the fruit to land, touch the ground. That's for our question 1. Now, for our question 2, it says a man moves 6 meters east and then 10 meters north 30 degrees east. How far is he from his starting point? Okay, let's represent this diagrammatically. There's a starting point. So as statement says, he moves 6 meters east. That means he moves due east. Okay, 6 meters. Okay, and from this point, he goes 30 degrees east to the north. All right, 30 degrees east. So from the north, we count from the north here, we count 30 degrees east. Okay, so this is current position, 10 meters. So we have to calculate his distance from this current position to this. So here we know here to be 90. So 90 plus 10. 90 plus 30 gives us this angle to be 120. Okay, so if we have this, we can use our cosine rule to solve this triangle. Okay, now let's call this C, A, and B. So this becomes a small b, a small a, and a small c. Bearing in mind that our cosine rule is c squared equals a squared plus b squared minus 2ab cos c. Okay, so looking for our small c, which is c squared equals a is 10 squared plus 6 squared minus 2 times 10 times 6 cos 120. Alright, so this becomes c squared equals 100 plus 36 minus 20 times 6, 120 cos 120. Okay, so C squared will be 136 minus 120 cos 120. Now 120 times cos 120 would give us 120 times cos 120 would give us, this becomes C squared 136 plus 60. Now cos 120 will give us minus 0.5. Now minus 0.5 times this will give us plus 60. So C squared will be 196. So our C equals root 196, which gives us 14 meters. So the distance between the mass current position and the starting point will be 14 meters. Now let's look at number 3. Now it says the density of water is 1 gram per cm cube, while that of ice is 0.9 grams per cm cube. Calculate the change in volume when 90 grams of ice is completely melted. Now we know that density, okay, our density is what? Mass over volume. Okay, our formula for density is mass over volume. Now, if we have mass over volume, here our density is 1 gram, okay, while we are looking for what change in volume when 90% is completely melted. So volume of ice will give us mass over density. So for us to calculate the volume, okay, of ice and that of water, it will give us mass over density. So let's say for ice, let's have it for ice, volume equals mass over density. Now the volume, our mass here is 90, and the density of ice is 0.9. Okay, and this gives us 10. Okay, 10 cm cube. Okay, now for water, our volume will be mass over density, which is the mass of water. The mass is still 90 all over 1, which gives us 90 cm cube. Okay, so now for us to find change in volume, our change in volume, sorry, this should be 100. Sorry, this should be 100 cm cube. Sorry. Okay, our change in volume, because this should be 0.9. Okay, this would be 90 over 9 over 100, which becomes 9 over 10, sorry. So which becomes 90 times 10 over 9. 10 times 10 will give us 100, so that should be 100. Our change in volume, okay, our change in volume will become volume of ice minus volume of water, okay, which is 100 cm cube minus 90 cm cube. So that will give us 10 cm cube. So the change in volume when 90 grams of ice is completely melted will be 10 cm cube. The volume of 1 cm cube metal ball increases by 0.0018 centimeter cube when heated through temperature theta. If the linear expansivity of the ball is 2.0 times 10 raised to the power minus 5 per Kelvin, find theta. All right, now for this, we are working on cubic expansivity, which we know that for our cubic expansivity is 3 times our linear expansivity. Okay, so if our linear expansivity is 2.0, that means the cubic will become 3 times 2.0 times 10 raised to the power minus 5, which gives us 6.0 times 10 raised to the power minus 5 per Kelvin. Okay, that will be our cubic expansivity. All right, now we know that for our cubic expansivity, we have it as change in volume all over the original volume times our temperature. Okay, so now having a change in volume as 0.0018, okay, that's a change in volume, all right, at 0.0018, then our original volume is 1, and our cubic expansivity, which we found, is this. So this becomes, and we are looking for temperature, remember, so our cubic expansivity times volume all over, okay, times volume times temperature equals change in volume. So temperature would become change in volume all over our cubic expansivity times volume. Okay, so here our temperature would be, theta would be, change in volume is 0.0018 all over 6.0 times 10 raised to the power minus 5 times 1. Okay, so this gives us our theta to be 0.0018 all over 0.00006. Okay, so we can have it as this will give us a theta equals, this divided by this will give us 30 degrees Celsius. So our theta will be 30 degrees Celsius, or, okay, since it's in Kelvin, 30 degrees Kelvin. All right, that would be our theta. Now, for the second question we have here, it says an electric oven plugged into a 220 source will consume what amount of electric current? Now, we know that our power equals voltage times current. Okay, now we are giving the power P as 500 watts, all right, and we are giving the voltage as 200. So our current will become P over V, which is 500 over 200. Okay, so our current will become 2.5. That will give us 2.5 amperes. Okay, sorry, this is 220, not 200. 220 volts. Okay, 220 volts. So 220 volts will give us 2.273 amperes. Our question 6 says the gravitational pull between two bodies is 20 newtons. Find the gravitational pull when the distance of separation is double. Okay, so if we have a body A and body B, all right, and the gravitational pull is 20 newton. Okay, now when the distance is doubled, that means our R
is doubled, all right? So our r squared, okay, now we know that F is directly proportional to 1 over r squared, okay? So now, if our r is doubled, assuming r equals 1, okay, so if r is doubled, r squared will give us 2 squared. Since it's doubled, 2 times 1 will give us 2 squared to make 4. So our new force here will be our 20 divided by 4, which gives us 5 newtons. So the force between them, when the gravitational pull between the two bodies, when the distance is doubled, would be 5 newtons.
The critical angle for a glass to air boundary is 45 degrees. What is the refractive index of the glass? Now, looking at our refractive index, we have it as refractive index we have 1 over sine c. Okay, now where at sine c, our angle here is 45 degrees, so our refractive index would be 1 over sine 45. Okay, 1 over sine 45, we know sine 45 to be 1 over root 2, so our Ri becomes 1 over root 2. That's for sine 45. So now, rationalizing as such, we have it as 1 over 1 times root 2 over 1. Okay, so this gives us root 2. So our answer for that would be root 2. Now, the next one says the volume of a fixed mass of gas is at 0 degrees Celsius is 200 meters cube. What is its volume at 273 centigrade Celsius? Sorry. What's its volume at 273 Celsius at constant pressure? Now, applying Charles' law, which says our volume over temperature equals V2 over T2. Now, our V1 here is, our volume here is 200 meters cube. Okay, T1 is, at first temperature is 0. Okay, so but this is at Celsius, so plus 273, which gives us 273 degrees Kelvin. Okay, then T2 would be 273 plus 273, which gives us 546. Okay, so now applying this here, our V1 is 200 over 273 equals V2 over 546. Cross multiplying, V2 equals 200 times 546 over 273. Okay, so now 273 here 1, 273 here 2. So V2 equals 200 times 2, which gives us 400 meters cube. So the volume at 273 degrees Celsius would be 400 meters cube. Alright guys, with this, we've come to the end of today's tutorials. If you've liked our class so far, don't forget to like and subscribe as it helps our channel to grow. Also share this link with your friends. Thank you. See you in our next class.